You're probably familiar with block diagrams, single-line diagrams, schematics, and wiring diagrams. And you're also probably familiar with the American Standard Device Function Numbers Table and the Diagram Abbreviations Table. In this unit, we're going to go over some other diagrams that may not be as familiar to you. You may not need to use these types of diagrams as often as schematics or wiring diagrams, for example, but when you need these new types of diagrams, you'll find that there's no substitute for them. This unit will cover connection diagrams, interconnection diagrams, raceway diagrams, and logic diagrams. We'll also talk about the equipment location index and logic symbols. We'll show you the general approach used in reading all of the diagrams shown in this unit. In this segment, we'll talk about connection and interconnection diagrams. The other types of diagrams we've mentioned will be defined later on in the unit. A connection diagram is a drawing showing the general physical location of all major components and the connection points of all wires within a single unit. An interconnection diagram is a drawing showing the wire connection points between different units that are electrically connected together. First, let's talk about connection diagrams. Connection diagrams are a tool that the manufacturer usually uses. However, if connection diagrams are used properly, they can be of value to you as a maintenance person in your work. This is a fairly typical connection diagram. At first glance, it may be confusing, but we're going to go over it and see if we can simplify it. The first thing we want to point out is the way it's drawn. The engineer or designer will specify the direction they were looking at the unit when the diagram was drawn. That's an important point. If you're not looking at the unit in the same direction that the designer was when the diagram was drawn, then everything you'll see on the diagram will be facing the wrong way. So always check the diagram to see what view it gives you. This one indicates that this drawing is a back view. The designer was looking at it from the back. Another important aspect of a connection diagram is the component identification. Components are usually identified by letters, and they're usually listed alphabetically, from left to right, top to bottom, starting with A and then continuing through the rest of the alphabet. If a unit has more components than the letters in the alphabet, then the designer will use two letters such as AA, AB, and so on. Let's identify the components in this diagram. This component is designated A. It looks like we've already violated the left to right, top to bottom layout, haven't we? But remember, we said that rule is usually followed. But on this connection diagram, the manufacturer, for some reason, decided not to follow the general rule. Here we see the letters TB. These letters can be found on the diagram abbreviations table. It uses abbreviations or initials to identify the component. TB identifies a terminal board. A terminal board is a device containing screws or studs, and it provides points for connecting wires. The studs are usually identified by numbers, and they're usually numbered from left to right, top to bottom. Okay, let's identify the remaining components on this connection diagram. Now, let's find component B. All right, there is no component B. Evidently, the manufacturer decided to save the letter B for use at some future time. The manufacturer may decide to add another component at a later date, and the letter B can be used to identify a new component. The remainder of the components do follow the listing alphabetically, and they are also listed from left to right, top to bottom. Component C is identified by the standard diagram abbreviation AM. AM represents an ammeter. Components D, E, and F are assigned device function number 51. Number 51 identifies an AC time overcurrent relay. Component D's device function number is followed by the letter N, meaning it's connected to a neutral. Up here we have two fuses identified by the letters UA. U identifies a fuse that is not a part of a component. The A identifies the particular fuse. Okay, let's look at terminal board A. The first thing we'll look at is the terminal board numbering system. It's numbered from top to bottom. These two small circles indicate a screw or stud connection point. Both of these are designated as terminal or connection point number 1 on terminal board A. All other screw or stud connections will be numbered consecutively from top to bottom. Now, let's look to the left of terminal board A. Here we have a whole series of letter number combinations. These letter number combinations indicate the wires that are connected to terminal board A. They're usually lined up with the stud so that you'll be able to identify what stud they're connected to. These letter number combinations will be the markings on the wires that are connected to terminal board A. This letter number combination identifies the component and the stud number on the component that the other end of the wire is connected to. In other words, the markings on the wires at terminal board A identifies the component that the wires come from. As an example, let's say this wire marked UA2 is disconnected from this terminal board, and you don't know which stud it's supposed to be connected to. Using a connection diagram, you can locate component UA, which is a fuse, and can locate stud number 2. And by looking at the markings on the wire connected to stud 2, the markings indicate that the other end of the wire is connected to component A, stud number 6. Now we know where this wire is supposed to go. We can connect it to stud number 6. That was just one example of how helpful a connection diagram can be. You probably won't use connection diagrams much in your day-to-day work, but when you do need a connection diagram, no other diagram can replace it. Now, let's take a look at an interconnection diagram. This is an interconnection diagram. Interconnection diagrams are, in general, the same as connection diagrams. However, interconnection diagrams deal with wires or connections between separate units. Components are identified in the same way as connection diagram components. They're identified alphabetically from left to right and from top to bottom. The wires connected to a component are identified by the letter identifier for the component and the stud number on the component that the other end of the wire is connected to. In addition, interconnection diagrams also assign a prefix number to identify the unit number that the wire comes from. Let's look at the interconnection diagram again. This unit is identified by the number 8. All wires leaving this unit will carry the prefix number 8, indicating that the wire originated in unit number 8. Let's say we're looking in this unit and we find a wire with the marking 7X3. The prefix number means that the wire came from unit number 7. The X means that the other end of this wire is connected to component X. The 3 means that it's connected to stud number 3. Okay, if you understand how to use connection diagrams, then interconnection diagrams are relatively easy. You use the same identification system with a prefix number added to identify the unit. All right. We just gave you an explanation of 2 additional diagrams that you as maintenance electricians can use. Before we go on to some other diagrams, look over the material in your text and answer the questions you'll find there. If you have any additional questions concerning any of the material covered so far, get them answered by your instructor before we go on. In the previous segment, we discussed a couple of diagrams that you can use to trace out circuits and make connections when the equipment is right in front of you. For the next 3 segments, we'll discuss the equipment location index and Raceway diagrams. We'll also talk about Raceway schedules, and we'll talk about Raceway notes, symbols, and detail. Only Raceway diagrams are actual diagrams. The other items we've mentioned are books or lists. We'll cover them in more detail later. The first thing we'll talk about is the equipment location index. The equipment location index is not a diagram. It's really a list. And actually, there are 2 lists that we're going to discuss that are a part of our equipment location index. Some equipment location indexes merely identify equipment. This one, in some cases, tells the location of equipment, but even though the book is an equipment location index, it does not always give the location. It uses standard number-letter abbreviations to identify equipment rather than the proper equipment names. Most modern plants use the standard letter-number combinations. Now, the equipment location index is usually rather long, so we're going to look at a few specific items. We'll show you an example of how the list could appear, and we'll point out some features that are common to the lists. This particular plant's equipment location index is made up for equipment that is part of 2 generating systems. In this illustration labeled 2L1, the first number designates the system. The letter will designate the type of equipment. The last number is a local identifier. The meaning of 2L1 is 2 for System 2, L for lighting equipment, and number 1 identifies a particular piece of equipment or component. Your plant's numbering system may not be like this, so you have to know how your plant is set up in order to use your location index. Now that we've explained what each number letter means, let's look at the example again. This example tells us that 2L1 is a lighting panel located at column C2, elevation 8 feet. We'll cover elevation and column numbers in depth later in this unit. But for now, let's talk about the equipment location index a little more. Earlier we said we would go into more detail about the meaning of the letter. Many equipment location indexes are locally prepared and fit local situations, but the letters used are pretty standard. The letter J usually means a junction or terminal box. Another example is the letter X. X usually identifies a transformer. Now that you've seen how this equipment location index is designed, let's talk about when it's used. Let's take a look at a typical Raceway diagram in the plant. We're going to locate a symbol on the diagram and identify it using the equipment location index. We're going to look at this diagram in more detail later on in the segment. Right now, we want you to look right here. As you can see, we have a symbol that is identified as 2X103. Since we've talked about the equipment location index, you can probably identify it from memory. But suppose you couldn't remember, or you hadn't been taught. How could you identify the symbol? Well, you'd use the equipment location index. Let's take a look and see what it is. According to the equipment location index, it's transformer 103. As you can see, the equipment location index does not give a location for the transformer. The reason could be that many transformers are found in a central location, or because the transformer is so large that it could be considered a location point itself. Whatever the reason was, this plant did not identify the location of the transformer. All right, that's an explanation of how part of the equipment location index might be set up. As we said in the beginning of this unit, we're going to discuss another part of the equipment location index. In this plant, part of the equipment location index is for motors. The index lists more detailed and practical information about motors than the first list did. Let's take a look. It's set up so that along the top there are some column headings that identify what information is located in the column under them. For example, this column identifies the service the motor would provide in a plant. The next column identifies the type of motor it is. The other columns further identify the motor as to the way it's mounted, its horsepower, its speed, and where it's located. Let's take a look at one of the motors listed in the index. We'll use MP12. This letter-number combination identifies the motor. Now, following this line from left to right, the first column under service tells us it's a service water pump. In other words, this motor drives a water pump. In the next column that designates the type of motor, we see the letters DP. DP means the motor has a drip-proof enclosure. The manufacturers designate a motor type depending on the type of enclosure the motor has. There are several types of motor enclosures. Drip-proof means that the motor is enclosed, but it does have ventilation openings in it. The openings are installed in such a way that moisture dripping directly on the motor would not go inside the motor. It's suitable for use in a damp area where there is no danger of moisture being sprayed into the motor. The next column we see in the location index indicates how the motor is mounted, usually vertically or horizontally. In this case, it's mounted horizontally. This column designates the motor's horsepower. The motor we're talking about is a 25 horsepower motor. Speed is the next column. This motor runs at 1,800 RPMs. The last column lists the motor location. The column number gives the column location for the motor in this plant. The motor location will also usually be given in terms of elevation. We'll discuss elevation in another segment. So, if you run across a number similar to the one we've just shown you on a diagram you're using, you can locate the number in the index. And from the index, you'll learn all the information you need to know to locate the motor. The two parts of the index we've shown you are a valuable tool for you to identify number letter symbols that you'll see on diagrams. Okay, take a few minutes to look over the information in your text. Also, if possible, get an equipment location index for your plant and see how it's laid out. Discuss what you find in your own plant with your instructor. If you have any questions, get them cleared up with your instructor before we go on. In the next two segments, we're going to talk about raceway diagrams. Raceways are any designed structure that cables and conductors follow in a plant. They can be a pipe-type design, which is frequently called conduit, or they can be racks on a wall or ceiling that conductors are laid in. Raceways can be long metal boxes called ducts, or they can be metal troughs that are frequently called trays. As you just saw, the term raceway can mean many things. Because the term raceway covers such a wide area of meaning, reading raceway diagrams can be difficult. A raceway diagram is a drawing detailing the specific raceway layout in a specific plant or building. In order to read raceway diagrams, you'll have to use a couple of books or lists that will help to guide you as you go through it. One of the books is called Raceway Notes, Symbols, and Detail. The other one is called the Raceway Schedule. The Raceway Notes, Symbols, and Detail book gives you an explanation of special or unusual symbols, and it defines the type of raceway. The notes state any special consideration taken when the raceway was built and installed. The detail section of the book contains drawings that show exactly how specific portions of the raceway are put together. It usually covers areas on the diagram that are too small or crowded on the main diagram to show detailed information. The other book we mentioned is the Raceway Schedule. It lists the raceway number, where it comes from, and where it goes, as well as what cables are in the raceway. The diagram alone is not really of much use to you, but when used with the books, you can learn almost anything you want to know about your plant's raceway system. Now let's take a look at a raceway diagram. As you can see, there isn't much understandable information on it. However, when we complete this unit, we'll have a better understanding of how to read a raceway diagram. This diagram provides us with some vital information about the plant that is not exactly related to Raceway diagrams, but it does contain a concept you must understand. And that concept is how to locate specific points in the physical plant. Now, most large structures or buildings are supported by beams or columns that are strategically located throughout the plant structure. These columns usually run from a foundation in the ground all the way up through the building to support the roof. The columns are usually laid out in a grid pattern. That means that they're spaced a certain distance apart. It resembles a large checkerboard. The columns can be laid out in any direction. However, in most large plants, they're laid out north to south. The plant we're talking about is laid out that way. Regardless of how your plant's columns are laid out, the first thing you must do is orient yourself on the diagram. The diagram we're looking at has an arrow that indicates north. Once you've established a direction on your diagram, then you can start to locate specific points in the plant. Usually, the plant's columns are assigned numbers in one direction, and they're assigned letters in the other direction. This is the standard symbol for a column. And as we said earlier, they're laid out from north to south. That means that the columns are numbered in a north-south direction. As you can see, there are numbers running along this side of the diagram. Here's north. The numbers start at the top of the diagram and become larger as they go toward the bottom. What about the columns that are laid out this way? In many plants, the columns are lettered in an east-west direction. However, this plant is just the opposite. The letters across the top of this diagram run from west to east. This exception to the general rule emphasizes how important it is that you learn how your plant is laid out. Now, armed with this information, let's see if we can locate a specific column in this plant. Let's use a column we talked about in the segment on equipment location indexes. Remember, we located lighting panel 2L1 in the index, and the index told us it was located on column C2. All right, let's locate column number C2. You can start either on the letter line or the number line. It doesn't matter. Let's start on the number line. We'll follow this line down until we find number 2. Keep this point in mind because we're going to use it again shortly. Now let's go to the letter line across the top and find C. Next, let's follow a straight line down the diagram until we're directly in line with the number 2. Here's the symbol for a column. As you can see, the column symbol is not identified on the diagram, but we know this is column number C2 because we followed the grid identification correctly. The columns in most plants are marked so that when you determine what column you're looking for, you can find it. Okay, we've seen how to locate specific points in the plant by using the north to south, west to east grid plan. But since most plants have more than one floor, how do we locate specific points that are several floors up? To do that, we use an elevation plan. Elevation is a location in height. Most plants have the elevation stated in feet and inches above or below a reference. Many plants use sea level as a reference. The elevation of this plant is based on sea level being the reference. Other plants may use different references. Other plants can use floors or stories as references. For example, the ground floor or the lowest complete floor may be the reference, and elevation is determined either above or below that point. Usually, the elevations are also marked on the columns. You won't have elevation marks every foot, but the columns are marked at each floor, so you will have a starting point. This is an example of what a typical column might look like. This is column D9. Your plant will have a reference, and you must learn what it is so that the elevation system will work for you. All right, what you've just seen is how plants are in general laid out, and you've been shown how to use the information to locate specific points in the plant, not only in a north-south and east-west direction, but also up and down. Okay, there's one other thing you should know. Equipment will not usually be located on a specific column. That might be impractical or impossible. but they will always be located near the designated column and elevation. In other words, the equipment will be located in a close enough proximity that once you locate the column and the proper elevation, you can find it. Why don't you find a Raceway diagram for your plant and see how it's laid out and how the columns are numbered? If you have any questions, take them up with your instructor. When you and your instructor are ready, we'll go through a Raceway diagram and see if we can use the information on it. We'll also look at the Raceway schedule and the notes, symbols, and detail book. In this segment, we're going to look at a Raceway diagram for this plant. Using the Raceway diagram, the notes, symbols, and detail book, and the Raceway schedule, we'll see what information about this plant we can extract. We may see some unfamiliar symbols. If we do, we'll look them up in the notes, symbols, and detail book to see what they represent. Okay, let's look at a Raceway diagram. As we said in the last segment, it does not give us much information. We'll look at the diagram's title block and see what type of diagram we have. Well, according to the title block, it's a Raceway diagram. It also tells us that it's for generating unit number 2. Here's a small section within the title block that gives us the diagram number. This is diagram number E844. That is an extremely important bit of information, as you'll see in just a few minutes. For now, let's get back to the diagram proper. These are the symbols for a Raceway. The symbols have numbers. Let's look up one of the numbers and see what we can learn about it. Let's look up this one, number YF220. The book that we want to use to look up the number is the Raceway schedule. Here's the Raceway schedule. As you can see, there's a lot of numbers in here. Many of them don't mean anything to us right now. However, one of the first things we see is the number E844. Up at the top of the page, we see that that is the drawing number, and that is the diagram we're examining. The book has several pages dealing with the drawing number. By searching through the pages, the specific Raceway can be found. The book lists the Raceways in alphabetical and numerical order. If we look up at the top of the page and follow it across from left to right, we'll see what each of these pieces of information mean. Here on the left side, we see that this number is the Raceway number. This second number, YF216, is where the part of the Raceway we're looking at comes from. The next number tells us where our part of the Raceway goes to. It's going to piece number YF221. The next part of the schedule tells us its size, that it's a tray-type Raceway, and its length. As you can see, it's only a very short piece of Raceway. The next bit of information gives the description of the cables in this tray. There are quite a few in this particular tray. The information following that tells us how many cables of each type are in the tray. Cable area is the size of each cable, including insulation. Total cable area is the total of all the cable sizes added together. The last bit of information is the percent fill of the tray. Percent fill means what percentage of the tray's available space is actually filled by the cables, and that's including the cable's insulation. Percent fill is important because the National Electrical Code sets a limit on the amount of fill a Raceway can have. The maximum is usually 40%. When the plant that you're working in was first constructed, the builder was responsible to see that the maximum fill of a Raceway was not exceeded. However, now that the builder is gone, it's your responsibility to see that when you're installing a new circuit, you do not run wire through a Raceway that is at maximum fill. You don't want to overfill a Raceway by putting more wires in it than it was designed to hold. Okay, that gives you some idea of what information concerning a specific piece of a raceway you can get from a raceway schedule. Now let's look at the raceway again. Notice these triangle symbols here. Let's check the symbol in the Notes, Symbols, and Detail book and see what they mean. This book tells us that they identify the end of a tray. If we look at the raceway diagram again, we can see that the number YF216 is on the diagram just before YF220. And there is one of those triangles between them. There's another triangle between YF220 and YF221. All right, let's sum up what we've learned about the raceway diagram. We know what diagram it is. We also know that it's a tray-type raceway. We know how to identify it from its numbers. And we learned by looking in the schedule book where it comes from, where it's going to, what size it is, what cables are in it, how many cables it has, what size they are, and what percent fill it is. We've also learned how to identify where it starts and stops by a symbol, the triangle. Well, that's quite a lot of information, but there's much more. Now let's see if we can use the raceway diagram for this plant and what we've learned already to find out where the tray is located. Remember the plant column system? Right here is the tray we're talking about. If we look to the right, we'll find the column numbers. Locate the number that lines up closest to this tray. Now let's locate the letter across the top that lines up closest to this tray. This tray is very close to column D9. The next thing we have to find out is the elevation of the tray in the plant. According to the diagram, the elevation for this tray is 23 feet, 10 inches. Armed with the information presented, you should be able to find the tray in this plant. By using the column letter number system and your plant's elevation system, you can locate and identify specific raceways in your plant. So learn your system. You'll find the information valuable. For now, take some time to look over the material in your text. Talk to your instructor about your plant's raceway system. If you have any questions, get them cleared up with your instructor before you go on.